Thank you for the invitation, and really glad to be here. It's probably one of the most technically inclined audience that I'm going to give the talk to. So this is work in progress, and really welcome questions and feedback, and really appreciate you being here. I'm going to try to make it so I know that not everyone is familiar with the topic, and not everyone is. Hopefully, some of you are somewhat interested, or all of you are somewhat interested. I'm trying to make it interesting, but I'm going to try to also emphasize the technical part of the method. So kind of being a health economist, you really used to giving talks to people in different disciplines. So along the sort of the technical spectrum. So I'm going to try to make this as technical as possible. But first of all, just kind of some acknowledgments. So this is joint work with my postdoc, Donghu Li. So he really did the lion's share of the work. So just want to acknowledge that. So today we're going to talk about the financial determinants and consequences of intergenerational caregiving among U.S. households using quasi-experimental methods. So first of all, just some background. So I know that it seems that most of the audience here are more sort of on the younger side, but obviously some of you have heard one way or the other that there's sort of wide global population aging. And in the US, actually family caregivers are the backbone of elder care. So there are more than 24 million Americans that are unpaid caregivers for older adults. So there are some key statistics, like for example, like about 2/3 of the caregivers are women. The average caregiver age is actually 49, so it's sort of on the middle to like old age side. And 36% are caring for a parent, and then about 60% are employed while caregiving. So this has become a very burdensome sort of public health issue. So there are a lot of actually background here that I'm not citing, but US doesn't have the best long-term care facility. So oftentimes when you have an older parent who needs care, there are not a lot of great options. So oftentimes family caregiver is sort of the fallback when you don't have, like, let's say, good quality nursing homes, or when you can't afford nursing homes. And Medicare does not cover long-term care, only Medicaid, and you have to kind of like quote unquote be poor to qualify for Medicaid. So there are a lot of issues with caregiving. And this is why sort of family caregiving is really important, because it's really taking on a lion's share of caring for older adults. So there are a lot of downsides from the literature on consequences of intergenerational caregiving. So meaning caring for your parents or your in-laws. So there are costs for caregivers across different domains. So there's a health side. Literature has found that as a caregiver, oftentimes you suffer from declining mental and physical health, which is not surprising given that caregiving is such a labor-intensive and work is also often sort of mentally taxing. And as a result, you experience increased medical utilizations. And on the side of employment, as mentioned before, a lot of the caregivers are still working. So in order to make time to give care, they have to often cut back on work. So it's either quitting jobs entirely, exiting the labor market, or just working fewer hours at reduced wages. So obviously that affects sort of the financial, the income that you're bringing in. And there's a lot of gender variation in there as well. So there's literature that shows that women are actually bearing the lion's share of the employment burden. They're forced to kind of reduce their labor force participation more so than men. So obviously all of this means that caregiving can really affect financial well-being of caregivers. So sometimes they actually have to cover, not just to provide care, but they actually pay for the living costs and other medical expenses of the people that they care for, especially if they live together. So because they often have to exit the labor force early, they have to so there's a disruption of the accumulation of social security benefits, which is the primary funding source for people after retirement. So all of that has potentially long-term negative consequences on financial well-being as well. So, but there's also important gaps in the research. So some gaps include that the prior literature mostly focus on just the primary caregivers, and they don't really take perspective from the household. So this is potentially a gap because more than 60% of caregivers are married or living with a partner. So obviously, if I were to give care, provide care for my parent, my husband is going to get affected as well. So it's sort of a joint process, right? And then financial decisions are oftentimes made in a household at the household level. So it becomes a household optimization problem rather than an individual problem. There's also little evidence on a long-run financial trajectory before and after caregiving. So a lot of times the focus of the literature is on a single dimension of finances, such as employment and wages, but we really need to take look at the whole comprehensive financial picture of what's going on if you're providing care. So that's sort of the objective of this paper is to address these gaps. So we're looking at things at the household level, and then we're looking at both the financial precursors of caregiving and the financial consequences of caregiving. The reason why we want to look at those, so I think typically in the US, intergenerational caregiving is optional, meaning that you're not forced to take care of your parents. You can put them in a nursing home if you have the resources. Typically, I think so I don't want to generalize, but I think in a lot of Asian countries, there's sort of more of a duty to take care of one's parents. Sort of that's the societal obligation to do that. Whereas I think in the US, it's less so the case. Obviously, it differs by family, and as I'll show you, differ by sort of racial groups as well. But in general, whether to give care for one's parents or in-laws is optional. So people select into caregiving on dimensions that could be financially driven. So we want to ask whether people, households that provide care to their parents, are they wealthier? Are they poor? Could they be motivated by bequest motives? So this is like, if I'm providing care, am I going to get money in return? Bequests or inheritance from my parents that I'm giving care to. So those are valid questions, and it's important in this context because then we want to understand who are the types of people that choose to provide care for their parents, and that could affect the consequences of well-being, caregiving, and the welfare in general in this dynamic. So next thing is like caregivers near retirement age may have more means to buffer the potentially negative financial consequences of caregiving. So the mean age is 49. So in this study, we're actually going to use a data source that look at older adults 50 and above to look at those people that are on a little bit on the older side. So when they give care, so typically they would have had longer time to accumulate assets. So maybe they are less affected by having to reduce wages and caregiving and all that kind of stuff. But on the other hand, they may have worse health themselves if they're older. So sort of understand how the financial dynamics works in this group is going to be interesting because they're providing a lot of the care for like their older parents, especially since people are now living longer and they tend to have dementia. So the care givers themselves can also be older. So lastly, which is I think a key statistical issue that I'm going to talk about today, obviously because of the endogeneity of caregiving, it's not randomly assigned. So we have to, if we want to talk about the consequences of caregiving, we have to address endogeneity here. So I'm going to use two different approaches. So the event study, which is basically a variation of the differences framework, and the instrumental variables. By the way, I just wanted to mention that feel free to ask questions anytime. Being in the econ discipline, economists are usually the worst in terms of just interrupting people, during talks. So I know that biostatisticians are way better, but feel free to ask questions. If anything is unclear, yes.
I know there's actually a difference oftentimes in econ papers I've read and stat papers I've read on the definition of indigeneity. So I'd love to hear definition here.
Great question. So what I'm talking about is unobserved confounding that would affect, whether someone provides care and obviously the consequences of caregiving. So basically the sort of the distinction between association and causation. Is that consistent with what you had in mind?
It's like a no unmeasured confounding assumption.
Right. So we're not going to make the assumption that there's no confounding. Oh. So we're going to, I think, basically a bulk of the empirical applied economics literature is to try to address unobserved confounding. So we almost never assume that there's no unobserved confounding because it's not realistic. Yeah. Any other questions? Yeah.
What is the American confounding?
Yeah.
Do you have like a set of variables to consider?
Yeah. So I think we're going in thinking, so again, I think it's really interesting to kind of to think about the differences in discipline here. So I think with economists, we usually take more agnostic approach. We're assuming that there's unobserved confounding, but because it's unobserved, we don't know, we can guess or make sort of educated assumptions about what there might be, but we try to always take approaches that could address confounding that we can't even think of, like, or can't even measure. Like, for example, I'm going to show you some evidence that people who provide care are actually people whose income is already declining. So for some reason, they're not making enough money outside of caregiving already. So even if they go into caregiving, it's not going to suffer, it's not going to affect their earnings or income as much. So that is something that we wouldn't really know before we do the study. I don't know if that answers your question. Yeah. So, but I think in terms of just conceptually, the kind of confounding that may go into, I think it definitely has to do with someone's financial status, right? Because obviously, if we think that caregiving is going to affect your financial status, then you're going to think more carefully when you're going in.
Financial status can be measured.
It is, but so that's the thing. If we want to both look at the financial, so if we think financial status can be a confounding, but we also want to look at how caregiving affects one's financial situation. So that is a little bit tricky. You'll have to tease out those two parts. Yeah. Obviously, things like demographics, whether you're a single family, whether you have a spouse that can share the workload, your age, your work status, your racial ethnic background, all of that can affect decision to give care. Yeah, so I think I did notice the one difference with sort of what we do things in econ is that we again taken a very agnostic approach in sort of approaching questions in the real world. We never assume that we know everything about the confounding, because otherwise then maybe you can measure it. But there are always things that you can't measure, but we can guess sort of what those things might be. I just want to ask a question. So how many of you are already familiar with difference in differences? Okay, so I think most of you guys, I actually have a little bit of a recap in there, a few slides. So I think for those of you who, I didn't want to assume that everyone, because it's a very widely applied method in sort of applied like program evaluation and applied economics literature, but I don't want to assume everyone is like super familiar. So I'm going to have a little bit, but what about event study? Has anyone heard of event study? Okay, two. Okay, good. So at least I'll have a more of a coverage on that. So just sort of some descriptions about the data. So we're going to use the health and retirement study data, HRS, from 1996 to about 2 decades of data. So if you're interested in any questions in aging, this is probably the best data source there is in terms of survey. So it's conducted every 2 years. So if surveys or interviews, I should say interview about 20,000 US older adults age 50 plus and their spouses. So spouses can be of any age. So they're nationally representative of US community dwelling older adults. So that's always great. So they have very detailed information on pretty much everything that you can think of in terms of sort of their health and socioeconomic conditions. They have detailed questions on cognition. So you can see if people have dementia, and to particularly have very detailed information on household finances. So they have income, spending, wealth, different sources of income, and wealth, and that sort of thing. And very importantly, for our study, they include caregiving activities. So basically, number of hours that you provide care and who you're providing care to. So they basically have all the key information that we need to do the study. Yeah. Yeah.
Just like do you have, since the surveys run 96 to 18, do you have like repeated measurements of their income? So if
yes,
that's the case, you might be able to tease apart if that's the income before they started caregiving or versus.
Yes, that's exactly what we're trying to do here. Yeah. That's the longitudinal nature is key. Yeah, you're absolutely right. Mm-hmm. So just want to define some key terms in terms of study sample. So our treatment group, it is defined as households with at least one individual. So by the way, I should clarify. So when I say household here, I mean either one person or 2-person households. There could be other people living in that household, but we're really talking about the person maybe with a spouse or without spouse. So households with at least one individual providing more than 100 hours of personal care and errand help to either parents or parents-in-law in a 2-year period. So it's as Gong was saying, it's a repeated measure. So every year we observe whether you provide care, and if so, how many hours. So apply this 100 hours cutoff, because it's has been used in this literature and using this data. But actually, I was gonna say that's actually one of the things that we can kind of look more into, sort of one could think about varying that threshold and see how things change. So 100 hours in a 2-year period is actually not too much. It's average about 1 hour per week. So 52 weeks in a year. So, but I mean, it's not trivial, even if you have to do 1 hour per week, it's not trivial. But one can think of sort of applying a higher threshold. But this is the operating definition that we're using. So for the control, we're saying that those are households where no individual provided caregiving at any point during the study period, provided that at least one parent or in-law was alive. So there can be no caregiving whatsoever. The reason why we wanted at least one parent to be alive is because we want to allow them to have the option of potentially provide care in the future. We think that they provide a better counterfactual than people whose parents are just dead and there's no possibility that they're going to provide care. So, but in our study period, they cannot start providing care if they are in the control. So total, we have about 5,000 households, 20,000 household years. Again, it's sort of every 2 years, but it's about 20,000 household waves. So treatment group has about 1,563 caregiving households. Control group has 3,556. Yeah.
So to be in a household, like they have to actually live in the household, the caregiver?
So great question. Not necessarily. They just have to provide care. So they can live with their care recipient but they don't have to.
So you could study how many years? 20 years?
It's about 20 years, yeah.
So a household will be non-caregiving at some point to become caregiving, right? How do you deal with that?
Exactly. So in order, so this is an important point, which I wanted to say. So in order to be in a treatment group, we have to observe the onset of caregiving. So we have to observe at least one period where you didn't provide care. So that we can actually look at the entire trajectory of how things were before you start providing care and how things were after.
So,
yeah.
You want to see the change, but when you say treatment group, it's a dynamic definition, right? Before becoming a treatment group, you are a control group or?
Well, so for the purpose of different diff or event study, so we label you as treatment group if at some point you start caregiving by this definition.
So,
Yeah.
I would like to understand that, because I mean, if you have time 0, then it means you go to the future to see. If you need to retrospect.
It's a retrospective.
Sure, it's still time 0. I mean, you're not doing that backwards now. Well, what's the definition of the exposure if it's not, like it seems to be.
Yeah, so so one thing I learned about interacting with Biost colleagues is that a lot of times there's I think sometimes it's just like semantics or differences in definitions. How about this? So the exposure is caregiving, but we look at what happens in the entire life cycle of caregiving from before and after separately between the treated group.
We'll see.
Okay.
I mean,
yeah.
naturally, it would seem like you would have an indicator of like, at any given time, is this household caregiving, yes or no? Maybe they'll be 0, 0, 0, and then at some point you jump to 1, right?
Yeah,
So that's what I mean, that it's sort of static. I mean, whether you are actually currently caregiving or not. Now you're saying, did you ever give care? Right? And that's how you're categorizing the group?
Yeah, so when we categorize the group, we did did you ever give care? But we did also take into account the 0, 1 in a history. Because that's important for differences. So yeah. Okay, but yeah, we can talk more about that when I get more into methods. So so measures, so the outcomes, we actually looked at much more than this list here, but to make sure we have time for methodological discussions, I'm mostly going to show the most important outcomes, which is total wealth. So basically how much money, net worth, how much money you have to live in the household. Your spending, which is basically your consumption, sort of how much money you spend on purchasing goods and services, and income. So how much money is coming in from like all sources. So transfers, which is a little tricky. So transfers is actually different from, so in HRS data, transfers just refer to money given and received from care recipients. So they're separate from like the spending or income. But we're gonna look at transfers separately because it's important in this context to see how much money you're actually giving to the people you provide care for versus how much money they're giving you, maybe to compensate for your time. So they're different from just like the regular income and spending. But they're gonna affect your wealth, obviously. So covariates, so there are a few standard things. So again, I know that we can't control for everything. So to give another example of things we can't control, how much you love your parents. To love them enough to provide care when, maybe there are fewer other good options. Like we can't measure that. So it's not possible to control for all confounding, but we can control for a few obvious things, right? So demographics like age, education, race, employment. So demographics, I think in this case, so these are actually fixed over time because these are older adults. I mean, with the exception of age, but age is just like the change is kind of a trivial, we'll just add one for every year. But education and race in the sample is considered fixed because these are adults way past school age. So employment can change over time, self-reported health, obviously number of household members, and the last thing is co-residence with minor children. So the assumption there is that if you have a younger kid that you have to take care of, you're less likely to provide care. If you guys think of anything else that we haven't captured in the covariates and think we should, let me know. So differences. So I know a lot of you are kind of familiar with that already, so I'm going to try to go over this quickly, but I just think it's good to kind of at least lay out the definitions, terminologies to make sure we're all on the same page. So it's typically used to study a binary treatment DI where I indexes units. So units can be obviously persons, in this case is households. So there are two periods. So we have a 20 period time. Well, actually it's more about like 10 to 12 weeks, but in the simplest diff and diff setting, you can just have two periods. So T equals -1 or 0, and treatment is implemented at T equals 0. So let yi know the outcome of interest of unit I at time T. So obviously, so I could be either treated or not treated, and then the T is 0, 1. So the treatment effect is identified as follows. So conditioning on, or the ATT, average treatment effect, conditioning on DI equals 1. So if the person was actually treated at time 0, our treatment effect of interest is the observed outcome at when the person is actually treated versus the counterfactual outcome at time 0. When the person, what would have happened if the person were not treated, right? So this is just a standard definition of ATT. Any questions here?
So why
Yeah.
one means, the one means,
This one?
I mean, like the for the observed one. So it's actually observed outcome rather than potential outcome?
Yeah, so so this is sort of, this is if, so if DI equals 1, this is if DI equals 1.
But for different households, they may have. So they may entry, they may like, so, but I mean, like DI should depend on time, right? The treatment should also depend on time.
So yeah, so you can, if it helps, you can forget about the household, like forget about the data that I told you about. So this is a very abstract, simplified setting of diff and diff. So there are only two periods. We only need to consider two periods. So treatment can only happen at the second period, which is time 0.
Okay, I see.
Yeah.
I see.
Yeah. That, yeah.
I know.
Okay. Okay, any questions here? Okay. So the DID estimator, which obviously, going back to the ATT definition, we can only observe, at time 0, we can only observe the outcome among the treated groups when they're actually treated. So we don't observe the outcome of the treated group at time 0 had they not been treated, because they are actually treated. So what we need is to approximate this counterfactual here. So how we do that is to use the information on the control group who were never treated. So we assume that the change between the two periods, the difference in the change between the two groups would give us the unbiased estimate of the ATT under two assumptions. So first one is no anticipation assumption, which means the outcome is not affected by the treatment prior to its implementation. So for example, if I know that next period I'm going to start giving care, I start changing my behavior in this current period. So that is not allowed. So that would invalidate this approach. So this would just mean that for the previous period, so the pre-treatment period, -1, these two outcomes, whether or not I'm gonna receive treatment in the next period, it does not affect my outcome in the current period. So that's no anticipation. And the parallel trends assumption is probably the more widely known assumption, which is that if there had been no treatment, the two groups, the trends and outcomes would have moved in a parallel way, such that the difference, you can kind of net out the difference in order to recover the ATT. Any questions here? Okay. Yeah.
Yeah, I guess with the data that you have, do you feel like this assumption one's reasonable?
So the short answer is no. I'm going to show you that is not. And then that's why we're going to have to do something else. So I think, so again, being a health economist, I do very applied research. We know that a lot of the time these assumptions are not true, and we have to find ways to deal with that when it's not true. So yeah, that's a great question. I'm going to show you some.
The parallel trend assumption is saying, so the people that were health, I mean, let's forget about the regular example, but the units that are treated versus not. If they had not been, considering if they had not been treated, you want to see the evolution, you're saying the evolution is the same. Right? So there's no heterogeneity in like hats. So can you relax this to include covariance, like within level of covariance?
Yeah, absolutely. So so this is obviously a very stylized example. So my next slide, so you can implement this in reality, you can incorporate covariance, so it's going to be a conditional parallel trends. So if you do that in a regression setting, where the YIT is again see the outcome of unit I at time t. So the DDT over there is the DD indicator. So it's one only for treatment group. So this indicator only turns one for treatment group in the post-treatment period. So that is exposure definition that we're talking about. But then we're trying to control for sort of permanent difference across units by this unit fixed effects. So alpha I, so it's one indicator for each unit. And then we can control for similar trajectories over time across units using the time fixed effects, delta t. And then we can also add covariance. So the covariance in this case would have to vary by time and unit, because anything that doesn't vary by time or unit would have been captured with these kind of fixed effects. So XIT, you can add covariance that vary by time and unit. And then we typically, in this case, cluster standard errors by unit. I think there's literature about two-way cluster standard errors. I mean, you can do different things with standard errors, which I'm not going to go into detail. So basically the OLS estimator beta hat is numerically equivalent to the DIP estimator without covariance. So if you pick out covariance, it's the same as what I showed you before, but typically people want to put in covariance because that really definitely helps with the parallel trends with the two assumptions. So this is what a typical DID looks like. Again, very simplified and stylized example. So you can kind of extend. So event study is really an extension of the simple DI, two-period DI. So you can extend it in different ways. So you can extend it to multiple periods. And you can also extend it to look at dynamic effects. So if you compare this estimating equation to the previous one, the really only key difference is this term. So instead of having one indicator for treatment or exposure, we now have multiple. So DI T minus J is a treatment indicator variable that equals 1 if treatment happens in period T minus J. So if J equals 0, that means the treatment is occurring at time T. if J is greater than 0, that means, this is an indicator for start of treatment J periods ago. So if J is smaller than 0, that means, the startup treatment is in the future. So J, absolute level of value of J period is in the future. So basically we have a separate indicator for every single time period relative to the onset of treatment. So that really allows us to examine evolution of the outcomes in the treatment, what we call treatment group, relative to control group over time, both before and after treatment. So you can think of it as a combination of like multiple with multiple periods. So again, so gamma, oh, sorry, it's typo, it should be beta, beta J. For J is greater than 0, capture the dynamic effects of the treatment. We typically normalize the period before treatment. So it's DI T minus 1. So we normalize that coefficient to 0 so that all the beta J's are interpreted as relative differences to the period before treatment. So I'm going to show you an example, hopefully. Well, actually, yeah, go ahead.
So if J is smaller than 0, that means future treatment, effect from future treatment.
So if J is smaller than 0, that means, I'm looking, let's say J equals -2, right? Because we know that we're normalizing -1 to 0. If J equals -2, then that means, we're looking at the relative difference among treated group to control group to their relative to their difference in -1 period. Does that make sense? So, yeah.
That's what allows you to anticipate whatever.
Exactly, that will allow us to detect if there are any movements in outcomes before treatment. Yeah, exactly. It also gives us a very direct test of the parallel trends assumption. Because if they're truly parallel trends, then all the beta J's, when J is smaller than 0, should be 0. So the difference between in other words, the difference between treated control group in the ideal scenario should stay constant over time until treatment happens. So that is sort of a very direct test. Any further questions about the event study? So this is, yeah. So economists use this stuff a lot because we don't have a lot of other tools. So this is one of the more powerful things. So basically just an extension of different diff. So we can kind of formalize the identifying assumptions in the event study case. So suppose the treatment starts at T equals T star. So the no anticipation assumption means that treatment has no causal effect prior to its implementation. So for any T is prior to T star, the actual outcome and counterfactual outcome would have been the same. Then the parallel trends assumption, you would just generalize it for all periods. So for all periods, and this sort of also applies for periods after T star. If there had been no treatment, again, if there had been no treatment, the treated group and a control group, their outcomes, the difference in their outcomes in any two periods should stay the same. So that's the generalized parallel trend assumption. So under the two assumptions, we have that each Bj for J is greater or equal to 0 would be the cumulative average treatment effect for a given period after the treatment. And for J is smaller than -1, so for any 3 periods, the beta J should be 0. So this second result at the bottom will be what we call the pre-trend test. Any questions here? Yeah.
So you're saying that, this assumption is testable, I think, partially testable. And so, does that mean that the assumption is stronger than you need it to follow the case? So we could have gotten away with the weaker assumption.
Actually, it's interesting. So I actually don't think we can really test this first, well, sorry. Yeah, so because the true parallel trends assumption would require that in the absence of treatment, this would hold for all periods of time, but we don't actually observe what happens in the absence of treatment. What we can only observe is pre-treatment. So this is a sort of a, what you call, like a tolerating. So what we can test is this. So this is a necessary but not sufficient condition, the parallel trends.
You could reject.
Yes, so if we reject this, then we definitely reject parallel. But we can, it's hard to definitively prove. We can only test the testable prediction. Any other questions? So just again, showing things in a graph. When you have multiple periods, you have t for -2. This is a toy example. When you have like 4 periods, so this is what control looks like. This is what treatment looks like. So in this case, then, in order to a perfect counterfactual for the control group, like would be like the dashed line. So in this case, we have violation of the because if the treatment and control is starting over there, and then this is how the control evolves, for the treatment group to evolve sort of over time with the same trends, it would have to look like the dashed line, but instead the treatment actually looks like this. So there's convergence, differential rate of convergence of outcomes in the pre. So there's a violation of pre-trends. Any other questions? Yeah.
Not if like, you ever say it's okay to do investigation, I guess for them to. You know,
So when you don't have multiple 1 and 2 periods of data, I've seen people do that. But that's not obviously not as rigorous because you can't test it. Doesn't mean that it always holds. I think when possible, obviously we always prefer multiple periods of pre-treatment data to be able to at least see visually whether it is possible. Okay. So in this case, so we can look at this in the data. So I'm going to show you a version of the graphs using our data that looks like this. So basically examination of pre-trend plots, meaning you can kind of plot means or some statistical units along event time, which is time relative to when the treatment begins. So this doesn't have to call it, this doesn't have to be calendar year. This would be time relative to treatment. So I just want to note one thing. So in our data, technically the treatment occurred at different years. So not everyone starts caregiving in like 2010. So they can start caregiving at different time. There's a whole nother literature on different event study that deals with staggered treatment. So there are things that are a little bit more complicated there, but I think the basic idea still holds. So I'm not going to talk about literature in this case. I'm just going to show you sort of, I think it's easier to kind of just saying that everyone is treated at the same time, but just knowing that they don't have to be treated at the same time. So because not everyone is treated at the same time, it's going to be a bit challenging when we plot this because we can always plot treatment along event time, but it's hard to do it for controls because event time can be different for different treated units. So what we do here is like we just apply a little trick, which is use that inverse probability weighting to reweight control observations for treated units in each event time. So let's say if like some, if there are units treated in, so like, how should I explain this? Yeah, so basically for each treated unit, we apply inverse probability weighting to find their sort of control counterfactual so that they can align on the same event study. And I'll kind of show you what I mean. So here's some summary stats, and I apologize, it's a bit small. So basically we look at the characteristic households 2 periods or 1 period before treatment. Those 2 years before treatment. So if you compare column 1 and 3, column 1 is a caregiving, which is a treated household or households that are eventually treated. Column 3 are the unweighted control households. So there are a few differences. For example, the control households have higher probability of not having anybody going to college. So they're less educated overall. There are higher probability of having non-white households. And then I think that there's a little bit higher probability of being unemployed. So on and so forth. But once you reweight them, they look a little bit similar. So we reweight them based on these characteristics, so age, education, college. So that the untreated or the control households can look more like the treated households at each event time. So this is just to show you the plots of the trends. So again, this is the outcomes for the summary characteristics. So these are the household financial variables that we're interested in looking at. So even just from the summary sets, you can see that the quote unquote treated households are a lot wealthier on average than the non-treated or the non-caregiving households. So after you apply the reweighting, the difference is a little bit smaller. But in general, the caregiving households are a lot wealthier. Any questions here? Yeah. Jing.
Well, for the treated group, I mean, their time zero is just when they start caregiving. For the control, how do you define the time zero?
Yeah, so for the control, so we take all treated group, like let's say at times, okay, so sorry, one more thing I wanted to mention is that, so our panel is not balanced. So each household can appear in the data for different periods of time, which means that even for treated, we get a different composition of treated group for each event time. So for example, for event time 0, we take the treated group that we have, and then based on their distribution of characteristics, we reweight the control group. We take all observations of the control group over all years, and we reweight them so such that they look like the treated group at time 0. The just inverse probability weighting. So this part is actually not essential to our methods. I just kind of do this to show you the trends so that we can align everyone on the same. So this is kind of the first set of descriptive statistics. So we're plotting trends of financial outcomes between treated and the reweighted controls, just to give you an idea of whether how a trend assumption is plausible here. So the total wealth is actually fairly parallel before treatment. The total spending, not so much, especially with this negative age. So I think in future analysis, we're probably going to drop negative age. I think things get very noisy there. Although like from -6 to 0, I think it's still not very parallel. So total income is definitely not parallel. So there's very clear pre-trends. Differential pre-trends between the caregiving household and non-caregiving household. So it seems that just from this graph, it would seem that the caregiving households were experiencing decline in income, relative decline in income, even just before caregiving starts. But I think one thing that's
The assumption is on the healthy practice. I know the needs of the practice. So how are you able to get to say something about that? Like, in order to identify data to get somewhere, you need to make an assumption. So now, based on the output, you're going back to see if the assumption on the healthy practice. So I mean, I include before that part of it can be tested. Maybe that's what you're getting at. If you're looking before in the past, and that's what you said that you could potentially test.
Yeah. So it's a good question. So I think these exercises are serving two purposes. One is that, so we said before that one of the, we don't just want to look at the consequence of caregiving, we also want to look at precursors. So what would predict someone selecting into caregiving? So this would help to tell that story. So what is going on with household finances before caregiving? The other purpose of this is that we're thinking of using event study differences because it seems to be appropriate setting, but we want to test whether the assumption is true. And then I just wanted to show you this, and then we're actually going to use ID because we know that the assumption is not true. So this is typically sort of what, so I think in the econ literature, if we say that we're going to apply these assumptions, we have to show that they're true or that they're plausible. So in this case, I'm doing the event study analysis to tell the story of what's going on beforehand, but also to kind of give evidence of whether the assumption is true or not. Yeah.
Like if you had not assumed no anticipation, you then couldn't.
I had not assumed no anticipation. Yeah, so if Vlad had not assumed no anticipation, then the event study or different diff cannot give you unbiased estimate of the average treatment effect on the treated.
Just to make sure I'm following the conversation, so is it that, like, strictly speaking, we can't test whether there were parallel trends in the pre-period because there is no actual control group that has a well-defined time zero, so it's still on like a counterfactual outcome that we can't measure, but we can try and estimate it.
So I think we can empirically test the pre-trans assumptions by looking at what happens in the pre-period. So if that test passes, then we have more confidence that we can use the event study approach to recover the causal effect. But if the test doesn't pass, and we have to do more than that. Right. Yeah, hi, yeah.
Maybe you're misunderstanding the study design setup, but can't by definition the household be one person, not with the caregiver? Right, so like household can like you and a partner, and by the taking care of the parent. So the household, the caregiver, that's kind of the house.
Right.
So the household size is you and a partner and potential care would be one.
So the person you provide care to does not have to live with you. And also, even if they live with you, we don't count them. So basically, our definition of household is just 1 or 2 person household. It's how should I say, artificial definition of household.
You're thinking of a couple, isn't it?
Exactly. Yes, that's also sort of how HRA.
So the couple has to be over 50 in the study.
So one of them have to be over 50 they have to be selected to be in the sample, and then whoever is their spouse is also going to be. So yeah, so our choice here is also kind of because of the data set structure. Because they elicit very detailed information on the respondent and their spouse. So everybody else, even if they live together, we don't know too much about. So like all the assets like money, wealth questions are for this person and their spouse. Yeah.
And so say if you start trying to not so bad. Just visually.
Yeah, C. Oh, C.
Okay, this is what we.
Yeah, I think this is medium. Yeah, so it's not bad. I'm also thinking that these are older people, so they should have more income, higher income than the average US household, if that's what you're. Oh, sorry, you're talking about the trends? Or like the trends are parallel? Yeah, so this one, yeah, you agree. So I'm gonna show you, sorry, this is just the first cut. I'm gonna show you the event study coefficients, which is with confidence intervals. Yeah, this is gonna show you the levels that, what the magnitude of money that we're talking about. But yeah, so I think one thing that is, we can obviously, people have different, but I can agree with it. I think some people would show this and saying that there's parallel trends. I've seen people do that, but.
I don't know.
Huh?
I feel.
Yeah. So, yeah, so, but I think one thing that is really interesting here is that on all measures, caregiver households are wealthier. I think that much we can say. There's pretty clear distinction. So in order to meet our definition of caregiving households, you're just wealthier than the control group. I wanted to show you this, sorry, just more trends before the event study. I want to show you this because we did different cuts of subgroups. And we found something very interesting. So, if you just focus on panel A here, we do this by race. So obviously we know that there are different subgroups of non-white, but because of our sample size, we weren't able to really dig into the different subgroups. But even if we just cut the data by white versus non-white caregivers, so you see that the red lines are white caregivers, and then the gray, like the round dots are white controls. And then the triangle, the green ones are non-white caregivers, and then the gray triangles are controls, non-white controls. So white caregivers are a lot wealthier than their controls. whereas it's the opposite. So it just seems that the well story kind of reverses depending on race. So we thought that we didn't really find this by any other subgroup. So we looked at this by college education, which is obviously another indicator of socioeconomic status. We didn't find that reverse of wealth comparisons. We thought this is really interesting. So it seems that if you're a white caregiver, you're more likely to be wealthier than the non-caregivers, but if you're non-white caregivers, the opposite is true. Yeah, okay. So, okay, I promise you there are gonna be some event study estimation. So do you think that the pre-trans test will pass with total wealth? Like, do you think that you can confidently say that the pre-trend, the sort of the pre-period coefficients are all zeros? So if I were to show this to the econ audience, they're gonna say, yeah, they're definitely pre-trends, or like, they're not gonna buy the story because you see very large confidence intervals here. Things are jumping around a little bit. I think with total spending, you can probably argue that there's plausible, like, parallel trends because the coefficients are fairly close to zero, even with large confidence intervals. But with total income, there's definitive evidence of non-parallel trends. We saw that, we can see that with the -6 and 4, at least the coefficients are simply different from zero. So there were higher which means that the caregiving household started off as higher income, and that became relative to before they started caregiving, exactly. So so if we believe that this contributes to decision of caregiving, which I think is plausible, I think the story here is that it's a story about opportunity cost. Because your income is already declining, you're not going to earn that, whatever you're doing to earn your income. You're not doing that successfully. Could be because you're running a business less successful, or because that you're already reducing your labor, participation. So you're kind of freeing up time to kind of provide caregiving already before the start of caregiving. What we're seeing here. Okay. So I want to show you the similar event study results for transfers. So transfers is just, again, money from two parents. So we do it looking at both the intent, the extensive margin, which is any transfers, the probability of having any transfers, or the amount of transfers. So for the amount, we do the inverse hyperbolic sine transformation of we actually did inverse hyperbolic sine transformation for all the outcomes that are dollar valued because they're really skewed. That approach has some drawbacks that is what we're going with right now. So the coefficients can be interpreted as percentage differences because they're in log terms. So basically what we're seeing here is that for transfers, the pre-trans are not as obvious, although one can argue that there's still a little bit of a pre-trans, especially for transfer of two parents. So prior to the start of caregiving, there's already a slight increase in all of these transfers to parents. Well, the transfer from parents is not as that, or I guess, I don't know. Again, none of the coefficients, the pre-period coefficients are significant, but there could be power issues. So one can only sort of infer from the division. So if we think that as long as the coefficient is not significant, it's not it's different from zero, which is what it means, then the only outcome that we definitely don't have pre-trans or parallel transfer total income. But if you think that even with insignificant estimates, some of those coefficients are indicative, then one can really start questioning whether we have pre-trans, parallel pre-trans at all for a lot of these. Oh, yeah.
What's the negative proportions for the transfer from and to parents?
Sorry, can you ask that
Yeah,
question?
the kind of A and C, there's some proportions.
Yeah.
For transfer, some of the proportions are negative. Like, what does that mean?
The difference is the whole thing.
Yeah, they're different. So yeah. So there's relative difference.
No, it's. Those are giving their.
Can you see that again?
the relative, is risk of the difference or the ratio?
So relative difference, so,
Relative.
yeah, so for example.
People who are giving care to people who are not giving care at that point.
Yeah, this, the -2 is baseline, right? So for example, if we look at 4, so this just means that, yeah, so compared to people who weren't giving care, and also compared to the time -2, people who gave care seems to have a decrease in getting transferred from parents. So it's relative decrease, from period -2 compared to the control group. But I think, again, if you kind of ignore or like you don't take the violation of pre-trans test is serious, then there's very obvious increase in transfer in either direction at the onset of care. Maybe this is what the event study is showing. Okay. So what can we learn so far? So again, this is sort of we're trying to explore in this case, what we can learn from the event study. So pre-trans tests clearly fail for at least some outcomes. So results cannot be readily interpreted causal, especially the income outcome. Oh, wow. I realized I'm already at time. Okay, so what should we do? Okay, let me try to use the next 5 minutes to kind of go through the IV exercise. I think I can probably skip some of the IV description. So in order to basically address, so I talk about the income, sort of declining income as opportunity cost that makes people select into caregiving. So because we know that the event study might be not sufficient to address the causal, sort of the unobserved confounding, we next turn to IV as sort of a second approach. So I'm not going to skip so I'm assuming everybody is familiar with instrumental variables. So I'm not going to like really, and then the two-stage least squares is sort of what people typically use to implement the instrument. So we use 2 instruments in this case that we think is maybe may be able to sort of address the unobserved confounding. The first one is parental ill health, which is with at least one of the parents or in-laws satisfying at least one of the 3 conditions and need for help with personal care, the presence of a memory disease, or inability to be left alone. So instead of looking at the start of caregiving, the action of caregiving, we're looking at the needs of parents. So sort of whether they start having a need to receive care. The second is the death of an alternative caregiver. So the death of one parent or in-law in a household where both parents or in-laws were alive in the previous ways. So it's a sort of a death of an alternative caregiver, and then maybe you feel more inclined to go in. So we first test the first stage, very strong for both instruments, which means that these instruments are strongly predicting the start of caregiving. And then the covariates look more balanced across the values of the instruments. Those are binary compared to the endogenous variable caregiving. It's not completely balanced, but it's more balanced than if you just look at compare the caregiving versus non-caregiving group. So one thing we did is that we try to combine the 2 approach. So we now define the treatment as the IV itself, and then we look at whether there's pre-trans. So we use the IV as a treatment. Oh, actually, did I skip the slide? Sorry. Okay, here. Yeah. So total spending and total wealth is sort of kind of similar, but with total income, at least like you don't see as significant of a pre-trend anymore. And then if you go to the death of alternative caregiver, the pre-trends with total income almost completely gone. So which gives us more confidence that these deaths of alternative caregiver would be a plausibly valid instrument in this case to address the endogeneity of whatever caused the pre-transfer total. And then this is the transfer. So I should say for the transfer variable, the pre-trans test looks not as good because these IVs might predict those outcomes beyond channels of caregiving. So quickly just show you the results. So for wealth, spending, and income, when we use instruments, we barely see any effects. So the story here is that caregiving does not really seem to negatively affect household finances. When we look at wealth, spending, and income, it does seem to cause increases in transfers, but those magnitude is pretty small. I have some discussion points, but basically I just wanted to show you a case where we're trying to approach a problem where there's some endogeneity, and then we're trying to use two different methods to address this. And combining the two methods can yield some useful insights. So I know that we're at time, but I appreciate any remaining questions or feedback, since we're still refining the study. Sorry about going over time.
Maybe one question there.
But, so race seems pretty important, race. Like, and if that would make me think different mechanisms.
Yeah.
Possibly are play for white people, are you saying that? And for white versus non-white, you can imagine, it was basically white people care when they can.
Yes, yes. So we did a lot of the subgroup analysis. We did everything by race as well. I just didn't have time to show all of that, but
That was my question.
I completely agree with you. We just have smaller sample size with non-white individual households. So that,
As relevant to the US, yeah.
yes, but yeah, thank you. I can do. Yeah.
Patty has a question on.
Okay.
Yes,
Patty,
thank you, Ting. Sorry, yes.
unmute
So sorry, this. Yes, can I ask the question? Do you hear me?
Now.
Okay. Can you hear me or no?
Yeah.
Yeah.
Yeah, okay, thank you. So this question was asked before, and unfortunately I didn't quite get the answer, so I apologize for asking it again. But sort of for the control group, how do you define this zero time point for the control group?
Inverse probability weighting approach. So basically for every event time. So for example, event time 0, when you have the treated households, and then at event time 1. So because our panel is unbalanced, the composition of treated households are a little bit different. All of them are in event time -1 and 0, but not necessarily in other event times. So for any event time for treated households, we take the entire group of control households across all time periods and then apply inverse probability weighting. So they look like the treated households at that event time.
I see. I see, but then
So we just have
that
different,
basically,
yeah, so we have different sets of weights for the controls, and each set of weights is unique to an event time.
okay, got it, thank you. And then how does that impact the test of whether sort of there's a pre-treatment difference in
So I'm sorry, so the inverse probability weighting approach is only used to create the trends. It does not affect, we didn't do that for the event study because we didn't need to. Because the
I
event,
see.
yeah, everybody is, we assume everybody is event time -1. Because
Okay, got it, okay,
yeah, event time outside of that.
Yeah. thank you.
Thank you for the questions.
Thank you. Oh, I think we are at time, and let's thank Jing again for a very nice talk.